Hello everyone. Am I audible?
Yes, sir.
Yeah. Okay. So for today's session, we will be solving some question on week 4 topics. Okay. And after that, we will move towards the programming assignment part 2. Okay. So let's start with the first question. So try solving first by yourself. Okay. And I will give you some time. Try to think how you will be proceeding towards it. Okay. And maybe try solving it, and then later we will discuss that. Okay. So the first question is on MLE, maximum likelihood estimation. Okay. So we have given this probability density function here. Okay. It looks scary at first, but uh, it is just like a normal PDF. Okay. Where
Sir,
our
question from activity questions, or you have put
no,
together
no,
these?
these are the questions that we made. Okay. They are not from activity or practice. Okay. So they are just for your extra practice. So this is the PDF of a distribution. Okay. Where the lambda and k are greater than 0 and x is greater than equal to 0. Our parameter for the PDF is lambda. Okay. K is some constant. Lambda is the parameter that we want to estimate using MLE. So which of the following option is the correct form of MLE for lambda? So maybe try. Okay. Try this question. So try solving it and later we will discuss it. Okay. Let me make a poll here. Okay. And uh, give the answer in that poll. Okay. Don't put it in the chat so that nobody can copy.
Sir, are you going to share these with us after the call?
Yes, yes, yes. Okay.
Okay, sir.
So this PDF would be available in the question for practice folder in the master folder. Okay. So I hope you can see the poll. Okay. So choose one of the options that you think. Okay. So just for the marking, this is option A, B, C, and D. Okay. Choose the answer which you think is the estimate for lambda based on MLE. So we will solve this question on 810. Okay. So those who joined just now, okay. So try solving this question. Okay, I will read this for you guys again. So this question is based on maximum likelihood estimation. we have given this PDF function, okay, in which x is greater than equal to 0, lambda and k are greater than 0. We have to estimate the parameter lambda. K is some constant value for us, okay, treat k as some constant. We have to estimate lambda using MLE. So which of the following option has the correct form for lambda MLE? Okay, I have created one poll. Try answering that in the poll. Okay, which option do you think is the correct? So are you guys able to solve it, or at least trying?
Pulkit, I just joined.
Yeah. Okay. Okay, let me rephrase again what we will be doing today. So the agenda for the today session is mostly with the solve with us question. Okay, I have 8 questions with me. Okay, I will present them one by one. I will give you guys some 4 5 minutes to try the question by yourself. Okay, and after that we will discuss the solution.
Okay, okay.
Like for this question, try solving it. I've created one poll. Okay, answer your in that poll. Okay.
Can you send it? I'm not able to see the message because I just joined.
Uh, like see, there's one on the what we say
Okay, okay. No,
bottom right. There's this activities icon. Okay, click on that and click on polls. You will see the poll option.
okay.
One more thing, your vote would be anonymous. Okay, nobody can see what you voted, so you can freely answer. Okay, except me, nobody can see. So just try to solve at least. Okay, even if the answer is wrong, no worry. Try solving it, but at least. Hmm. Okay, so now maybe we will. Should we move towards the solution? or if anybody is who is still trying to solve it. Okay, then let's solve the question. We have given the following PDF. Okay, let's note down the PDF of the function. Okay, f of x given lambda is k by lambda x by lambda power k minus 1 e power minus x by lambda power k. Okay, so this is the PDF that was given to us. Now we have to find the MLE. So for first thing that we need is the likelihood function. Okay, so the likelihood function would be what? Just the product of across all xi values. So xi given lambda, that is n a by lambda into xi by lambda power k minus 1 e power minus xi divided by lambda power k. Okay, so I hope till likelihood this is clear to everyone. Now what is the next step that we will be doing?
We're taking log.
Yeah, we will take log both sides, so that is we'll find the log likelihood.
Yeah.
Yeah, done. Okay, we will take the log likelihood for this, and because of that log, this product will turns into summation, and it would become log of k by lambda plus k minus 1 log of xi by lambda. Okay, and just remember we are taking the natural log here. Okay, so because of that this would turns out only minus xi by lambda power k. Okay, is this logarithm part clear, everyone? Good. Okay, now first we will basically simplify this so that we can get a more good form. So let's simplify it. It is log of k by lambda. Okay, now plus, okay, let's k minus 1. So now tell me, can I write this as log of k minus log of lambda, right? For this, because they are in division, so this would turns out in minus, and similarly for here also it is k minus 1 log of xi minus log of lambda. Okay, and here just xi by lambda power k. Okay, anybody has any doubt till now? Okay, I hope no. So let's simplify it further. Log k minus log lambda plus k log xi. Okay, let's do it here. Okay, see, these two terms does not have xi in it, so they will become just n log k and log lambda, and the summation part would only apply here. So k minus 1 summation from I equal to 1 to n log of xi. Again, this term also does not have any xi, so we can just directly write this as lambda, okay, and summation from I equal to 1 to n xi by lambda or k. I hope it is clear till now. Anybody has any doubt?
The k minus 1 is multiplied to whole of this term.
Yeah, this it would multiply. Okay. Okay. So
Could use to last term, even to last term.
Oh, yeah. Last term where? Okay, somebody wanted it to reiterate. Okay. Okay, so see, this was our PDF. Okay. So the likelihood of it would be just multiplication for all xi. Then we write our PDF. When we take log both sides, so it would be log of this term, and because they are in product, so it would split in plus, and this power would come in multiplication with log of xi by lambda, and because we are taking the natural log here, so this would just become xi by lambda power k. Now we are just simplifying it more, so it would become log of k minus log of lambda. This part here also split into log of xi minus log of lambda, and this would remain as it is. Okay, till now is it clear? Okay, so the next is, because these two terms does not depend on xi, okay, the summation is from I equal to 1 to n, but these two terms does not have xi, so they would basically be just simply added n times. So it would become n log k minus n log lambda. Okay, and this k minus 1 would be getting multiplied, and basically I have taken the summation inside of this. Okay, so I'm writing k minus 1 summation from I equal to 1 to n log of xi, okay, minus n log lambda, okay, then this term here. Okay, so anybody has any doubt till now? Okay, till this part is it clear for everyone how we are simplifying? Okay, good. Now the next step that I will be doing is basically I will multiply this k minus 1 inside of this. Okay, so n log k minus n log lambda plus I will leave for this part, that is log of xi, I will leave it as it is. But for here I will multiply, and you will see why we are multiplying it, because it will become minus kn log lambda and plus n log lambda, and this minus sign is here. Okay, so the only thing we did from here to here is we multiplied k minus 1 to this. Okay, for this I have not multiplied, I have written this like this. Now is anything that you can cancel out here? Are you able to see that you can cancel anything here?
Second term.
Yeah, okay, so this n log lambda negative, and here we have positive n log lambda. Okay, so we can cancel these two out, so we will left with n log k plus okay minus we have, let's keep them here. So I put this term here. Okay, that's why, because I'm taking summation at the end. k minus 1, summation from I equal to 1 to n, log of xi, again summation from I equal to 1 to n, xi by lambda power k. Okay. Till now, I hope it is clear. Okay. Now the best thing that we will be doing here is we will ignore the constant term here. Okay, because what's the next step after log likelihood? We will take the derivative, right? So in the derivative, the term that does not depend on lambda, because the parameter that we are estimating is lambda. So the term that does not depend on lambda will automatically become 0. So in our log likelihood, we will ignore all the terms that does not contain lambda parameter. So this term here does not contain the lambda parameter. So we will remove this. Also, if you see, this term whole also does not contain the lambda. But these two terms we will ignore because they does not have lambda. So when you take the derivative, they will automatically become 0. Okay. So the term that we will left with in your final log likelihood is negative kn log of lambda and negative summation from I equal to 1 to n xi by lambda power k. Okay. Is it clear till this now? How we did simplify it? Okay. So if it is clear, the next step is just take the derivative and set it to 0. Okay. So we'll just take the derivative with respect to lambda. Okay, that's the next step. So tell me what will be the derivative for this quantity. The first one, what will be
Minus
the
k by
derivative?
lambda.
Good. Okay. So the TL of k lambda is minus kn by lambda. Now what about the second one? Summation from I equal to 1 to n xi by lambda power k. Okay.
Then
We are
summation
hmm?
I is equal to 1 to xi
Yeah.
lambda to the power k is constant.
Yeah. Oh yeah. Or the only thing that you have to take the derivative with
Lambda
is
to the
lambda.
power k.
That is 1 by lambda power k. Okay. So maybe for simplicity, try just imagine that your term is only xi by lambda power k. Okay, and try differentiating that. And the only thing there, it's just that the summation will get it. Okay. So how will you? What will be the form that you will get after taking the derivative?
Minus kxi.
Say over lambda square.
Sorry, what? Can you repeat?
So minus xi over lambda square.
Minus xi.
Minus kxi.
Okay, minus kxi
Multiplied by k.
minus kxi. Next. Minus kxi
To the power k minus 1.
power k minus 1.
Minus is outside.
Okay, minus is outside. Anything more?
So multiplied by 1 by lambda square.
1 by lambda square.
No, sir. That is k
Okay,
minus.
so let me rethink, sir.
That is k minus 1. K should be outside, I think. K should be outside. Sir.
Okay, so you mean this form minus xi by lambda whole power k minus 1 and k, like this. Okay.
Sir,
Yes.
you can write it xi to the power k into lambda to the power minus k.
Xi to the power k
Into lambda to the power minus k.
You mean like this?
This above term, sir, you can write xi to the power k into lambda to the power minus k. Summation of I equal 1 to n.
Okay.
Above term, sir, summation of I equal to 1 to n, we can write xi to the power k into lambda to the power minus k.
Okay, xi to the power k into lambda power
Not in this,
k.
sir.
So,
I want to do one more step in this above summation part.
okay. Okay, let's do it
I
now.
want to, yes.
Okay, let's proceed now. I just. Okay, so this term, okay. First, just try to take the derivative. Okay, let's forget the summation part, that summation is there. Only let's just focus on xi by lambda power k, and think that we have to just take the derivative for this. So in that also, just think that xi is the constant, because the variable that with respect to which we will be taking the derivative is lambda. Okay. So first, if I just have 1 by lambda power k, what would be the derivative of it? Only just 1 by lambda power k.
Minus k.
Minus k.
1 upon lambda to the power k minus 1.
Okay. Try thinking about it. Will
K
it be
plus
k
1.
minus?
K
Yeah,
plus 1.
k plus. Okay. So I hope this derivative is clear to everyone, because you can write this 1 by lambda power k as lambda power minus k, and just how you like do the normal derivative of x power n. Okay. So if you just the term x power n, how you do it? N into x power n minus 1. So just try doing this. Okay. So this is what lambda power minus k. So from this you will derivative it minus k time lambda minus k minus 1. Okay, and it would become minus k times 1 by lambda k plus 1. Okay, so the same thing only we will be doing here. Okay, so we will just think that it is because xi is constant for us, so xi will be here. So let's say what is the term? Summation I equal to 1 to n xi by lambda power k. So first I can write it as summation from I equal to 1 xi power k by lambda power k. Now we have just only 1 by lambda power k. If I will be going to take the derivative, okay, there's negative sign on. Okay. So if we will be going to take the derivative, as we've seen before, it would be minus k, okay, and on the denominator it would be lambda power k plus 1, and because everything else, this summation xi power k, they are just some constant, so a equal to 1 to n xi power k. Okay, so that could be simply k upon lambda power k plus 1 xi power k. Is this derivative clear to everyone?
Yes, sir.
Okay, so the derivative that we got is this k upon lambda power k plus 1 summation from I equal to 1 to n xi power k. Okay. Next step is we will set this derivative to equal to 0 and just find that lambda. Okay. So that is the final step. So copy this down. Okay, so we'll set this derivative setting to 0. So it would be minus kn by, okay, maybe we can take the k common from here and we'll get minus n by lambda plus 1 upon lambda power k plus 1 summation from I equal to 1 to n xi power k equal to 0. Now can I divide both sides by k? Can we divide both sides by k?
Yes,
To
sir.
get rid of k. Now just remember the reason, because it is already given in the question that k is greater than 0. Okay, if it was not given, we cannot do that unless it is for sure that k is not equal to 0. Okay. Because it is already given that k is greater than 0 or k is not equal to 0, I can write this form as minus n by lambda plus 1 upon lambda power k plus 1 summation from I equal to 1 xi power k equal to 0. Okay. One Okay. Now I will divide both sides by lambda power k plus 1. Okay. Multiply both sides by lambda power k plus 1 so that this denominator we will get rid of that. Now for this expression minus n by lambda, okay, if you multiply it with lambda power k plus 1, okay, what you will get if you multiply this minus n by lambda with lambda power k plus 1?
Minus n lambda to
N
the
lambda.
power.
Correct. Okay. So we'll get minus n lambda power k plus, now because we are multiplying with lambda power k plus 1, so it would be just summation from I equal to 1 to n xi power k equal to 0. Now it's easy to simplify. We will get lambda power k equal to 1 by n summation from I equal to 1 xi power k, and the lambda at ml is 1 by n summation from I equal to 1 to n xi power k the whole power 1 by k. Anybody has any doubt in the solution?
Can you summarize the question?
Okay, for sure. Solution is too long. Okay, so in the question we started with, we have given a PDF. Okay, that is this. Okay, and where lambda and k are greater than 0, our parameter that we have to estimate is the lambda. K is some constant that we don't care. Okay, so we have to estimate using MLE. The first step in MLE is to find the likelihood function. So the likelihood function is just nothing but the product across all xi. Okay, so the density function, and this denotes the product. Okay, so now I have just written the density function that was given to us. The next step in MLE is to take the logarithm. Okay, so the log likelihood, because of that this product will turns into summation. Okay, and as they are in multiplication they would turn into addition, but because we are taking the natural log, so this term would become just minus xi by lambda power k. Now we are more simplifying it, like because they are in division, so due to log property they would turn into log of k minus log of lambda Similarly, we will do here, and they will split, and this term remain as it is. Now we notice that there are some terms like this and this, okay, and this that does not depend on xi, okay. So they will just simply be added n times. So we will just write it as n log k minus n log lambda, and this k minus 1 here I am taking the summation inside because this term depend on xi. Again, this log lambda does not have xi term, so again it would be just n log lambda, and again this one is depend on summation, so it would be summation from I equal to 1 xi by lambda power k. Now what I am doing next is I am multiplying this k minus 1 inside of this, so it would become n log, this is as it is, and this part is also as it is. On multiply this k minus 1 with negative n log lambda, we'll get minus k n log lambda and plus n log lambda, and this term remain as it is. We will cancel these two, and on the last term that we will get is this n log k, and I am bringing this minus k n log lambda here. The summation remain here, and this last summation here. Now because again there are some terms like this and this, they don't depend on lambda, and because the parameter that we are estimating is lambda, so when you take the derivative they will anyway become 0, so we can ignore them here also. For the final function, the log likelihood that you will get is this minus k n log lambda minus summation from I equal to 1 to n xi by lambda power k. Next is we will take the derivative with respect to lambda. So for this it is simple, it would be just minus kn by lambda. For this just do it how you do the 1 by lambda power k, okay, just how we do for that derivative, just do it like this, and the rest other things are constant, so it would become like this. Anyway, I have written the derivative part here. Next is we will set the derivative that we got to 0. We will take the k common from both the equation, and because it was given that k is greater than 0, that is not equal to 0, so we can cancel the k, and the simplified term is this. Next we are multiplying both sides by lambda power k plus 1, so that we will get rid of this denominator. So when you multiply this minus n by lambda with lambda power k plus 1, we will get minus n lambda power k, and for this it would just vanish, so this summation term. Now rest is just you take it this side, cancel out the negative term, take this n here, so you will get this, and just take the kth root, you will get lambda hat ml. Okay, anybody has any doubt in this?
Okay, sir, it's clear.
Good. So this is the solution. This is the second question. Okay, it is based on Bayesian estimation. Okay, the question says, suppose that y follows a binomial distribution with parameter n and the probability theta. Okay, so that the PMF of the y given the parameter theta is given by this. I hope everybody remembers the PMF of binomial. Okay, it is n choose y theta power y into 1 minus theta power n minus y for y equal to 0 till n. Suppose that the prior PDF of the parameter theta is the beta distribution, okay, whose PDF is given to us, okay, and find the posterior PDF of theta using Bayesian estimation. So what would be the posterior PDF? Anybody remember? If you use a beta prior for binomial distribution, what would be the posterior PDF you will get?
It will be a beta.
Yeah, beta with what are the like parameters of the beta?
Beta plus
Alpha.
alpha plus nt and beta plus n failure.
Okay, okay. Okay. So, yeah, you are correct about the beta. Okay. So I hope this question, I will just directly present the solution. Okay, and go through it because I hope this is the simple question and no. Okay. So anyway, I will repeat. Okay. So for the Bayesian estimation, uh, we know that posterior is proportional to prior times likelihood. Okay. The prior that was given to us is sorry here, the beta distribution. So this is your prior. Okay. Posterior, the likelihood is, we will take the likelihood for this. Okay. This is the likelihood function. And again, this n choose y here would be constant. Okay, it does not depend on our theta, so we will ignore
Yes.
this. Okay, so the part that we will left here with theta, and if you take here, it is theta power y, here it is theta power alpha minus 1, so it would become alpha plus y minus 1. And same for here, it is n minus y and it is beta, so it would become beta plus n minus y minus 1. So this is similar to beta distribution. The parameters are this: alpha plus y, beta plus n minus y. Anybody has any doubt in this question?
Now, sir.
Okay, good. So the third question is on EM algorithm. Okay. Consider a 1D data set minus 3, comma, minus 1, comma, 1, comma, 3 with k equal to 3 mixture of Gaussian. Using EM algorithm, we try to estimate the mean and variance of the Gaussian component. Suppose the output of the E step in an iteration is given by this matrix. Okay, this matrix R, which is of order n cross k. N here denotes the number of data points. K is denoting the uh, number of components. Okay, so k is in column wise, n is in row wise. Okay, now how these entry represents, each Rij entry, that is each this entry in the column, or sorry, in this matrix, corresponds to the probability of xi data point belonging to component kj, that is lambda ij. So that means if I talk about this entry, this is fourth comma 1. Okay, fourth row, first entry. So this is the probability that the fourth data point, that is this 3, okay, given this 3, this belongs to the component 1. Okay, that is the conditional probability, or we say the posterior probability. I hope everybody remembers how you find this lambda ij. Pi k into nk divided by summation from I equal to 1 to k pi k nk. Now let mu hat 1, mu hat 2, mu hat 3 be the updated mean in the m step after e step, and calculate the summation of all the three means. Please try solving it. Okay. First of all, how you are going to find these missing values a, b, c, and d? Can anybody tell me the value of a here?
0.2, sir.
0.2. Yeah, correct. And how did you find it?
Summation equal to 1, sir.
Okay. We know this fact, right? That okay. summation from k equal to 1 to k lambda ik. Okay, this would be 1. Now the way to remember this, if you fix any data point, the probability that this data point belongs to component 1 plus component 2 plus component 3. Okay, if you sum up these probability, they will come up to 1. So let's say this is the first data point. Okay, that is -3. The probability that it will belongs to component 1 is 0.3. For component 2 it is a, and for component 3 it is 0.5. So if you sum these up, you will get 1. You should get 1. So based on that, first you will find the value in the matrix. So the a would be 0.2. What about b? B would be what?
0, sir.
0.
0.
C, what about C?
0.25.
0.25.
Okay. And D is
0.5.
okay. Now you have got your matrix. The only thing you need to do now is update the mean. And anybody remember the formula to update the mean in M step? It is the weighted average, right? So what is the formula for that? What is the formula for updated mu k?
Don't remember, sir.
Okay, no bit. Okay, so I hope you remember this, that it is called the weighted average. Weighted average of what? We take the weightage of these conditional probabilities. So we will fix the component, okay, and varying over n, that is the number of data points, and then we will take this conditional probability as our weightage. Okay, lambda ik xi, right? Summation from I equal to 1 to n lambda ki. Okay, if this lambda wouldn't be here, then it would be just the normal your what we say normal average, but this updated mean is called the weighted average, and here the weight is given by this conditional probability. And if you want to remember how which summation should be come here, whether it is we are varying over number of data point or the number of components. So see, because you are updating the mean of one component, so you'll fix that component and varying your lambda across different data points. So fix the component varying over data here. So that means after you find this ABCD value, to update the mu1, okay, so to update, if mu1 hat, what you will do, you will multiply this 0.3 into this -3 plus this b value that we got is 0, so 0 into this -1 plus now c value we got as 0.25, so that is for 1, so 1 into 0.25 plus this is 0.1, so 0.1 into here it is 3. Okay, so this is your numerator, this value, and the denominator is just the summation from all these, so that is the summation of this one column. Okay, so if we look at the solution part, this is the matrix. We all have calculated the matrix. The updated mean is given by this weighted average. Okay, this was the mu hat 1, okay, that we were calculating here. 0.3 into -3 plus 0 into -1 plus 1 into 0.25 plus 0.1 into 3. So that's the same numerator, and you would divide by the lambda value, that is this. Okay, 0.3 plus 0 plus 0.25 plus 0.1. Okay, so you get this updated mean. So Is this clear to everyone? How you calculate this updated mean in M step?
Yes, sir. So will we get the matrix always in question?
It is not necessary. You might also get the table.
Okay.
Okay. I mean, it's the same thing. And whether you get the table or matrix, it's almost the same thing. Okay. And sometimes it might also happen that you need to calculate these values. Okay. It might not given to us. You need to calculate these, and then based on that, you need to update. So
This
one of
lambda ik like
yeah. Okay. So we have one question on lambda ik also. How you calculate the lambda ik?
Yes, sir. Can you please explain how to we compute mu3 hat?
this.
Mu3 hat. Okay, for mu3 hat, you will take these probabilities because we are talking about the third component. Okay, so that is 0.5 into -3 plus 0 into -1 plus 0.25 into 1, okay, plus 0.5 into 3, okay, and divided by the summation of all these, okay. And if you look at here, that's what we have done here.
Okay, sir. Thank you.
And the question is asking for the summation of all the updated mean, that is -0.29.
So, sir, we will compute until the number of columns. Is that right? In
Yeah,
this case, we
because
have 3 columns for
yeah,
mu3 hat. But if we had like 5 columns, then we will have to
then
compute.
there would be 5 components, okay,
Okay, sir.
because here the column corresponds to the number of components. So that's why we have 3 columns, because there are 3 components and 4 row for each data point. Okay, let's look at this here. N is the number of rows, k is varying here. Okay,
Sir, what is the meaning of this component? Is it the number of mixtures?
yeah, number of mixture, component, mixture, cluster,
Got it,
all
sir.
set. Should we move to our next question? Okay, now this question
Yes, sir.
asks us this question now asks us to calculate the lambda ik values. Okay, it is not directly asking you, but to answer this question, if you see the hint, it is telling you to use posterior probability. The posterior probability means the same, the lambda ik. Okay, so if you read the question, a GMM is used to model a data set with 3 components. Okay, now for a given data point, that is x equal to 6, the likelihood for each component are as follows. Okay, probability of x given z equal to 1 is 0.2, and given z equal to 2 it is 0.3, and given z equal to 3 it is 0.5. The mixture probability for the components are pi1 equal to 0.4, pi2 equal to 0.3, and pi3 equal to 0.3 also. Which component is more likely to have generated this data point? Okay, so what you have to check is, given the data point that is x equal to 6, the probability that it belongs to cluster 1 or component 1 or mixture 1, whatever you want to say, what is this probability? Again, given the data point x equal to 6, what is the probability that it is coming from cluster 2? And same, given the data point x equal to 6, what is the probability that it comes from component 3? Calculate all these 3 probabilities. Whichever has the highest value, that component is more likely to have generated the data point. Okay, and if you remember from our discussion from last session, we talked about this soft clustering and hard clustering, that EM does soft clustering and k-means does hard clustering. So this is kind of related to that topic. Okay, here EM will be doing the soft clustering based on the probabilities. So whichever has the highest probability, the data point belongs to that component. Is the idea clear to everyone? What we are doing in this question? Is it not? Okay, let's me try again. So first of all, we have given the component probabilities. Okay, that is pi 1, pi 2, pi 3. We have given the probabilities of choosing this component, right? Now, what is this probability corresponds to? Probability of x given z equal to 1. Okay.
That the data point x equal to 6 will go into cluster 1.
No, this is the probability that if you choose component 1 and sample the data from that component. Okay, this is that probability. It is basically the normal distribution value. Okay, so if you remember our story for sampling from GMM, what we do, we first choose the component. Okay, the probability of choosing the component are these, and then we have chosen the component, we will sample our data point from that component. Okay, so it is that probability that given we have chosen this component, that is the first. Okay, we are sampling the data point from that component, and that probability is 0.2, and similarly 0.3 here and 0.5 here. Okay, now we are asked that which component is more likely to have generated this data point. That is, given the data point x equal to 6, what is the probability that it belongs to component 1? Okay, that is this probability. Probability that given the data point x equal to 6, what is the probability that it belongs to component 1 or component 2 or component 3? I hope it is visible how that these two are different probabilities. One is x given z, in which first you are choosing the component and then sampling from that component. Here you have seen your data point and now you are trying to estimate from which component it must have been. Yes, Ravi. Ravi.
Yes, sir. Yes, got it. Just a
Sir,
second.
Hmm. Yes.
actually what we have to find here.
We have to find is
You
which component is more likely to have generated this data point. That is, given this data point x equal to 6, what is the probability that it belongs to component 1, component 2, component 3? And whichever has the highest probability, the data point belongs to that class component. Okay, so you have to calculate these probabilities. Probability of z equal to 1 given x equal to 6. Probability z equal to 2 given x equal to 6. Probability of z equal to 3 given x equal to 6. Calculate these three probabilities. Whichever is highest, that component is your answer. Clear?
like we have to use Bayes theorem.
Yeah, Bayes theorem. Check. Okay. So if you are going to write this, okay, this probability here in Bayes theorem, how will you write it? If you want to write this probability in terms of Bayes theorem,
Probability of x equal to 6 given z equal to 1
good,
into probability of z equal to 1
good,
divided by probability of x equal to 6.
good. Okay. Did you have given? Did you know this probability?
Yes, sir. It's given and
Yeah, it's
these
given.
three. Yeah.
What about this?
Except pi 1.
Yeah, pi 1. Now, what about this?
It is summation
Of all, it's one.
It's basically the summation for all these probabilities. That is z equal to 1, z equal to 2, z equal to 3, right? That is the total probability. Okay, right? That is the
So,
probability of x. Yes.
it should be one answer then.
Okay. You mean the answer is component 1?
No, probability of x equal to 6.
Yeah, the probability of x equal to 6 is the total probability, right? So it would be like probability of x equal to 6 given z equal to 1 multiplied with
Yeah.
probability of z equal to 1 plus probability of x equal to 6 given z equal to 2 multiplied probability of z equal to 2 plus yes. Clear?
Yes, sir. Clear.
Okay.
Sounds.
The only thing that we did is Bayes theorem. If you don't remember Bayes theorem, then the same type of formula we discussed when we were discussing the EM. Okay. In the EM also, the formula that was this. Okay. That is pi k into the probability that given we are choosing the component, the data set, data point is sample from that, and summation across all. Okay. Now only thing that you need to do is just calculation. Okay. I hope the question and the concept is clear. What the question is asking and how we are approaching it. Clear for everyone?
Yes, sir. Clear.
So what we are doing here is just uh, calculating the usually pi 1 into probability of x given z equal to 1. Okay, for all the three components, and for denominator we have to sum all these. Okay. Now we will compute the posterior probability. Okay, that is z equal to 1 given x, so it would be 0.08 divided by 0.032, that would be 0.25, and for z equal to 2 it would be 0.09 divided by 0.32, so somewhere around 0.28, and for z equal to 3 it is 0.46. Okay, so the component with the highest probability is more likely to generate this data point, that is component 3. Okay, any doubt anyone in this question?
So can you please summarize this? What were the steps in this?
Okay, so in the question we have given one data point. Okay, and we have given the mixture probability also, and also we have given that if you choose this mixture or this component, that is z equal to 1, 2 or 3, the probability that data point is generated from that is this 0.2, 0.3, 0.5. And the question asks which component is more likely to have generated the data point. We have given the hint, that is using posterior probability, that is given you have seen the data point, the probability that it belongs to cluster 1 or component 1 or mixture 1. And same way you have to calculate for all the other cluster or component also. Using Bayes theorem, we can write this probability as this. That is probability of x equal to 6 given z equal to 1 into probability of z equal to 1 divided by probability of x equal to 6. Probability of x equal to 6 you can write using the total probability as summing across all the components. Okay, that is z equal to 1, 2 and 3. We'll sum this probability. Okay, that is this numerator part. Here we are doing just for 1. So for denominator we will sum these probability for 2 and 3 also. That would give you the probability of x equal to 6. This is the marginal probability also for GMM. Okay. Now all you need to do is just take one each time and divide and see which one is higher. Okay. Sometimes in the exam these probability also you need to calculate. Okay. These probability also might not given to you and you need to calculate them. Okay. Basically you need to find the Gaussian distribution value at x equal to 6 given some mu k or sigma k. Okay.
So then to actually compute these, something would be given, right? Any additional information?
Yeah, that is mu k and sigma k. Okay.
Yes, sir.
That would also be given to you. Okay. And then you need to calculate the Gaussian distribution value at x equal to 6 with mu k and sigma k. Okay. using the density function of Poisson. Okay. And rest is just same.
So, sir,
So
in
I,
this question,
yes.
data point, they are asking just at x is equal to 6.
Hmm.
But is it just one data point of, there could be other data points as well, right, in the same data? Or
Yeah,
actually,
yeah. Hmm.
so if they asked, let's say they could have asked x is equal to 5 or anything else, right? So
Yes.
it will not make any difference whether it's
Yeah,
6,
yeah, yeah.
5 or
Just
any
x
other
equal to
data.
6. Yeah, I just chosen one fixed data point. Okay.
Okay,
Any other
sir.
data point. Okay. Something would be given to calculate the probabilities. Okay. Just like here, we have directly given you the probabilities. Okay. So I don't need to calculate them. But if they were not given, then they must have to give you the mu k and sigma k. Okay. Just a minute. Oh, okay. Uh, my pencil ran out of battery. Okay, so I will have to speak just verbally for now. Okay, what it is not getting charged. Okay, I guess some problem. Okay, now it's working. Okay, so was this question clear to everyone? The fourth?
So, sir, another doubt in the same question. So
Yeah,
z is equal to 1 refers to component, or what is z here? Is for
yeah,
the other is
component.
here? Okay, sir.
Z is for component indicator. Okay, just like in K means we have Z as the component indicator.
Yes, sir. Yes, sir.
Okay, sixth question. Oh, sorry. Fifth. Okay. Where is the fifth one? Oh, okay. 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 This should be fifth. The fifth question. A data set has n natural numbers. Okay. If we assume a Poisson distribution with parameter lambda as the probabilistic model, and what is the likelihood function? What is the MLE for lambda? For hint, you are given the Poisson distribution. Okay. So again, the question is on MLE. So I will wait you guys to find out. Okay. So as these type of question, I hope you have seen this in stats too. So try finding it out. How you will find the MLE for this, and what would be the likely, what would be the MLE for lambda? Or does anybody remember what would be the MLE?
Yes, it should be either sigma xi by n.
So sample mean?
Yeah, yeah. It would be sample
Yeah.
mean. Okay. So so anybody need me to compute everything, or just by solution it would be fine? Okay, let me try some steps. Okay. So the likelihood function, first they are asking for the likelihood function for this. So the likelihood function would be given by, again, the product from I equal to 1 to n. Okay, probability of is xi given lambda. That would be the simply e power minus lambda, lambda power xi by xi factorial. Okay. So just the simplicity, I can write it as e power minus n lambda and lambda power summation from I equal to 1 xi divided by. Okay. So this would be the likelihood function. Anybody has any doubt in this likelihood function?
No, sir.
No? Okay. Good. Next step is we will take the log likelihood. So when you take the log likelihood, we will again take the natural log. Okay. So the log likelihood will become ln of e power minus n lambda plus ln of lambda power xi minus okay. So this would become minus n lambda because of natural log. This would become the summation here would come ln of just lambda, and here it would be okay xi factorial
So it would be 0, no lambda.
yeah, it would be anyway. We can ignore this term.
Yeah.
Okay, because this term does not have the lambda that is we are estimating, so we can anyway ignore this term. So this would be just okay the log likelihood that you will get when you will differentiate it with respect to lambda. Okay, you'll get derivative d lambda minus n. What would be the derivative for this?
1 over lambda multiplied by summation of I to n xi. So this term remains as it is, multiplied by 1 over lambda.
Good. Okay, we will set this to 0 and we'll get lambda as 1 by n xi. Okay.
Can you go up once again? The likelihood function once.
Yeah. Okay.
Like we found the likelihood by using pi and then PDF of Poisson.
It's PMF because Poisson is a discrete
Yeah.
random variable. Okay.
Okay, PMF.
PMF. Okay. Just put the PMF and just simplify it a little bit. Okay. Because this term does not have xi, so it would be just e power minus n lambda. And here it would go in the power, the summation. Oh, sorry. Here it should be, yeah, it would be summation. Okay. Because you will be multiplying lambda x1 into lambda x2 like that, so it would come in summation. Okay, and then on the denominator it would be just pi. Okay,
Okay, sure.
see,
Clear.
anybody has any? Okay, so maybe we can look at the solution also. So this was the likelihood and this is the final form that we will get. Okay, I guess match this lambda should be here. Okay, lambda equal to 1 by. Okay, otherwise minus n and this 0 should be here equal to 0. Okay, any doubt anyone in the previous question? Okay,
No, sir.
it's again simple MLE, okay, with the Poisson distribution. Now the next question is on Jensen's inequality. Okay, look at the following graph. We have given the 4 graphs A, B, C and D. There are 2 questions. First question is select the option which satisfy the inequality for lambda 1 and lambda 2 between the range 0, 1 and lambda 1 plus lambda 2 equal to 1. So we are taking 2 lambda 1 and lambda 2 such that they satisfy the constraint that they belongs to 0 and 1, between 0 and 1, and their summation is 1. So which of the following function graph out of these 4 satisfy this inequality? What do you think? Which of the following function?
So D, sir.
Option D, sir.
Okay. Yeah, option B. Any other option? Just one more thing. You only need to check at the point x1 and x2. Okay, that is these 2 points. Only in this point, which of the following function
A
satisfy?
also.
Yeah. Okay. A also satisfy, but only in this point. Okay. So because it is just asking only the point x1 and x2. Okay. So if you draw the line, right? Now what does this inequality means? This inequality means if you just join these points, okay, the straight line that you will get should lie above the curve of the function. Okay, because this is basically the inequality for convex function. Okay, for concave the sign would be reverse that we use for Jensen in our EM algorithm. Okay, but as we are only checking for these 2 points, so if you just join these two, the straight line will always lie above the curve. For here also, but for this, sometimes it is above, sometimes it is down. So this is also incorrect. For this, it is always the above. Okay.
Sir, can you please explain which curve you are referring to?
Okay. So for the first a function, okay, if you just join these two, okay, the inequality means this inequality that is less than equal to this inequality refers the convex function. Okay, that is if you join these 2 points, the straight line that you will get should lie above the curve of the function between those 2 points. So between those 2 points, the curve function goes like this, and straight line is always above that. So that's why for A it's satisfied. For B, this is the straight line, and the curve is always below it, so it also satisfies. For C, sometimes it is above the straight line, and sometimes it is below the straight line. And for D it is always above, so it is wrong. So only A and B are correct.
Okay, sir. Thank you.
What about the second part, which represents the convex function?
Same A and B, sir.
Option B, sir.
Okay, one is saying A and B, one is saying only B. So why not A?
Because it's
Because
not for every lambda.
not at all the points.
Not at all the points, not the lambda on all points. Okay, so that is if you draw any other line on this curve, on this function curve, like let's say I choose these 2 new points and draw the line. Okay, by taking the same lambda that I am taking here. Okay, I just change my point. Now this function curve, sometimes it is above the straight line, sometimes it is below the straight line. Okay, so it is not a convex function. For convex function, this inequality that is here, it should satisfy for all points. Okay, across any point, if you choose any 2 points, okay, and join them using a straight line and take some lambdas value like this. Okay, basically this inequality represents this, that if you choose any 2 points on a convex function curve and join them with the straight line, the straight line will always lie above the curve of the function. That is for convex. For concave, it will always lie below the curve, just like for this. Okay, because this function is a concave function. For the straight line, if you choose any 2 points, it will always lie below the curve of the function between those 2 points. Anybody has any doubt in this question? No? I hope the difference between concave and convex is clear. Okay. and in another word you can remember, for convex function, the maximum always exists and it would be the global maximum. For concave, it would be, oh, sorry, I said minimum, yeah, sorry. Okay, for convex function, the minimum always exists and that is global minimum. For concave, it would be maximum, that would be global maximum. Okay. The seventh question is also on GMM. So let's read the question. We are trying to fit a GMM with k equal to 3 on the following data points. At some tth round in the EM algorithm, the following are observed. What are these representing? Lambda 3. Well, what does this mean by? The ith element of this vector represents this probability. Okay, that is, the point to represent that the first data point, that is this, given the data point, it belongs to component 3. Okay, given you have seen the data point 2, it is coming from the component 3. That is again your lambda ik. Okay, but here we are fixing just for the component 3. And what will be mu 3 and pi 3 after the maximization step in 3th round? Okay. So first of all, how you are going to calculate mu k? What is the formula for that?
Summation, sir, summation, same formula, sir, we in the previous question.
Yes.
Summation of I is equal to 1 to n lambda 1 k xi over summation of I 1 lambda k.
Lambda ik
Yes, sir.
xi.
Xi over summation of I 1 to n then lambda ik.
Okay. So this we have seen this before also. Okay, how you calculate the mu. Okay. So for mu, what you will be do? 0.2 you have given, and you will just take the data point. Okay, and just multiply and divide by the summation of these. Okay. So let's do it here. So it would be 0.2 into 2. Okay, this plus 0.3 into 1 plus 0.1 into 3 plus 0.6 into 2 plus 0.1 into 1 plus 0.5 into 2 plus 0.4 into 0, 0.7 into negative 3, 0.1 into 0 plus 0.2 into 2. This is your numerator. Now what would come in the denominator? Summation of these or this? Which would come?
Lambdas.
Yeah, okay. The summation of these. Okay, just simplify it. You will get your updated mu k. Okay, updated mu. Now, how you calculate the pi k? Okay, how you calculate the pi k? That is updated probability for selecting the component. Nobody remembers? Okay. So the formula for updated pi k is similar. Lambda ik divided by n. It's just the mean of the posterior probability. Okay, just simple mean. You just have to find the mean. okay, of the posterior probability for the kth component. Okay, so that
So
is
for
just
this
it.
question, we have to just sum up this lambda 3 and divide by the number of, right,
Yeah,
points.
so there are, I guess, how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Okay, so just sum these all, divided by 10. That would be your updated pi k, and this is your updated mu k. Now, what about sigma k? What is the formula for updated sigma k? It is also weighted variance, right? So how will you calculate?
There is summation I is equal to 1 to n lambda ki xi minus mu k is whole square.
Yeah,
Divided by summation I is equal to n lambda
yeah,
ki.
correct. Correct. Okay, so they are similar. Okay, so maybe if you are not able to remember in one go, okay, just focus on the main part. Okay, that the mu. Okay, sorry, the mean is the weighted average. Okay, and the weighted the quantity from which you are giving them weightage is the posterior probability. That is lambda ik. Okay, and similarly, your variance is also weighted variance. Okay, and the mean this pi k is just the average. Okay, that for posterior probability.
Sir, are you writing somewhere?
No, I'm not writing. Okay, mostly in the exam we don't ask the variance part because the calculation would be too lengthy for that. Okay, so but still, okay, if you remember the mean part, variance is the similar. Okay, nothing new. So I hope this question is clear. Should we move towards the next question? Okay, the final question for today. After that we will solve the programming assignment.
Sir, after this, can we please have 2 minutes break before starting
Yeah.
programming?
Yeah, sure.
Thank you,
I
sir.
would love to do that. Okay, so the final question, we have n IID samples from the exponential distribution with lambda given as the parameter. Exponential is a continuous distribution, so it would be have a PDF. Lambda is said to follow a gamma distribution with alpha and beta as the parameter. Then find the posterior. Okay, and find the posterior mean for alpha equal to 6 and beta equal to 2. The data points are these. Okay, so first, given you have exponential distribution with lambda as parameter, you know your prior belief that lambda follows the gamma distribution. You have also given the PDF for gamma distribution here and the PDF exponential, both are given to you. Okay, how will you find the posterior? How will you calculate the posterior distribution from prior? So posterior is proportional to what?
Likelihood into prior.
Prior is your gamma distribution, and you need to calculate the likelihood for exponential. Multiply these two, you will get your posterior distribution for gamma distribution. And the next it is asking you to calculate the posterior mean for alpha equal to 6 and beta equal to 2. So first you have to check what posterior distribution that you will get. Okay, so what will be the posterior distribution that you will get? What will be the posterior distribution if you choose gamma distribution as your prior for exponential distribution? Okay, we have to solve it. Yes.
I'm not sure, but beta, sir.
No, it's wrong. Okay, so maybe try. Okay, as this is the last question, so let's try for 5 minutes. Okay, you guys try for both. First calculate the posterior and then try calculating the posterior mean also. Okay, so at 9:40 we will solve this question. Try till then. Let me make just one more point here, that the term here, this, okay, this term, okay, can be treated as constant. Okay, this whole term would be some constant with respect to lambda. Okay, so you can ignore this, so you can just take this only for your calculation. Okay, so anybody got the answer? What would be the posterior distribution? Okay, so let's start. So posterior, okay, it is proportional to prior into likelihood. Okay, so the likelihood for the uh, exponential, okay, it would be product xi, so that would become lambda power n e power minus n lambda xi. Okay, okay, minus n lambda summation from I equal to 1 xi. Okay, oh, minus lambda x1 x2. Okay, okay, is this clear? The likelihood part. Okay, now in the prior as I said, this term here is constant. Okay, so the term only that we need is this. So let's put it. Prior is lambda power alpha minus 1 into e power minus beta lambda. Your likelihood is lambda power n e power minus lambda xi. Okay, so these two have the same base, so it would become lambda power n plus alpha minus 1 into e power minus, we can take the lambda common, and it will become beta plus summation from y equal to 1 to n xi. Anybody has any doubt till now? No? So which distribution form it is taking? Is it gamma again? Compare it. Lambda, okay, alpha minus 1, so alpha minus 1, then e power minus beta into lambda, so e power minus lambda into that. Okay, so if you start with exponential distribution, by choosing gamma distribution as your prior, the posterior distribution is also gamma distribution. Okay, with the parameter okay, so this is your gamma distribution, so it would have parameter n plus alpha and beta plus I equal to 1 xi. Okay, anybody has any doubt about the posterior distribution?
So usually for gamma, we just consider alpha and beta as parameter, right?
Yes.
But n plus, but you have written here n plus alpha.
Okay,
And beta
see.
plus.
Here, the alpha and beta are the parameter of the gamma. Okay, and the variable that it is taking is lambda. Okay, here also we are posterior probability, we are trying to estimate the lambda. Okay, so the parameter that it would get changed to, the alpha would in the posterior, after our prior belief, it would have alpha, it would become alpha plus n, while the while for beta it would become beta plus summation from I equal to 1 xi. So just like in our, when we have Bernoulli and we are taking the beta prior, the updated belief, that is our posterior, would also become beta, and our parameter gets changed to alpha plus nh and beta plus nt, right?
Yes, we are just adding, but parameter still remains alpha and beta, right? We will just add
No,
whatever we get.
This combined would be your new parameter. Okay, so this whole combined, you can take alpha dash, and this is your beta dash. Okay, this whole combined would be now your parameter. Okay, basically like alpha dash and beta dash, the value would be this, n plus alpha and this. Clear? Now the next step in the question is find the posterior mean if you have alpha equal to 6, beta equal to 2, and these are your data points. So what is the mean, or how you find the mean for gamma distribution?
In this case, that would be alpha dash or beta dash.
Yeah, correct. Okay, but that is the updated alpha and beta ratio, not.
Yes, sir. You have already written as alpha dash, which is updated one. So I.
Okay. Yeah. So alpha dash and beta dash, this would be your posterior mean. So alpha dash is alpha value is 6 plus number of data points. So 1, 2, 3, 4, 5, and 6. So that is 12. The beta dash is beta, so it is 2 plus summation of all. So 2 less than 3, 4, 5, 6, 7. Okay. So I hope it is true. Okay. So 7 plus 2. That is 9. So this is your alpha dash and beta dash. So the mean would be 12 by 9. So it is
1.3 something.
4 by 3. Yeah. 1.3. Okay. Anybody has any doubt in this question? Okay. So anybody has any doubt in the whole, all the questions, 8 questions that we solved today?
Actually, sir, I think we will have to refresh our stress too. At least I have to refresh my
Yeah, for the
revisit this
MLE and
concept.
Bayesian,
Yes,
you
sir.
need to do. Okay.
I have actually forgotten, sir. All when I was in stress too, I remembered everything, but now I have forgotten.
Yeah. Yes, Ravi. Any doubt?
So, sir, please share the note and the
Please share the
note and the
No,
PDF which you annotated.
annotated PDF you want.
Yes, sir, both.
Oh, both. Okay, both. Okay, I will upload the both. I
yes,
will
sir. We
upload.
also want. Yes, sir. I also want.
Yeah. I mean, like I am going to upload in the main. Okay, I will upload both the PDF, the annotated one and the original one. Okay. So yeah, the next is we will be discussing the if okay, nobody has any doubt, right, in the all the 8 question that we discussed today. Okay, good. So the next thing that we will discuss is the programming assignment part 2. So let's take a
Sir,
5-minute break.
please. Yes, yes, sir. Yes, sir. Thank you,
Okay.
sir, very much, sir.
Let's take a some time break, and you guys also can go and refresh. Okay, and we will discuss the programming assignment part 2, that is on GMM and EM. Okay. I hope. Hello. Should we start?
Yes, sir.
Okay. So
Sir,
yes.
sir, please share a link of the collab, sir. It's not opening for me.
Okay. Try it. Okay.
Thank you.
So just copy paste this link. Okay, in your browser, and this will be the collab file that you will see. Okay. Click on the file, save a copy in drive again. Okay, so that all the changes that you made get saved. Now, click on the connect. Okay, I have already connected it, so it will not show. Now again, the first piece of the cell, okay, contains importing numpy matplotlib. Okay, and just like before, we are changing the plot figure size. Okay, this basically change your figure size from default to 8 cross 8 and the font size to 10, and just simple importing. So let's move towards the question. We will understand the GMM. So in the previous part, we have seen this simple sampling. Okay, sampling from simple distribution like Bernoulli normal. Okay, now we will move towards the GMM part. Okay, and again, GMM has two steps. First, we will pick the mixture K. Okay, based on the uh, distribution governing it. Okay, and that means the probability. Okay, based on that we will choose the mixture, and then we will sample the point from that kth Gaussian selected mixture. Okay, so problem 1, consider a GMM with k equal to 3. We have given these mixture probabilities here. Okay, they are starting with 0 indexing. So perform step 1 of the sampling process by choosing one of the three mixture based on the above distribution. Call that value k. Okay, now if you remember in our last session of programming assignment, we discussed how you can choose something, okay, with the probability. So anybody remember the code for that? How will you do it? Yes.
Was it x is equal to some number and then size?
No, with respect to RNG, what was that method? What was that attribute? RNG dot we tried, right? First we tried RNG dot integers, then RNG dot what was that, from which you can give the probability that you want with this probability or something.
So random.
No, that will give you just a random number. Okay, but we want with respect to this specific probability.
Choice, sir.
Yeah, correct. Choice. Okay. So it was RNG dot choice. What's the parameter that it takes? The first parameter is the array of the numbers that you want. Okay. So we want the mixture 0, 1, and 2. Okay. So you will pass 0, 1, 2. Okay. The next is the size parameter. Size. So that you want, because you only want to select 1 point. Okay. What is the next parameter that it will take? We have chosen the array. We have selected the size that we want. Now left what?
Probabilities.
Yeah, how do you denote that here? What is the symbol that governs that probability here?
P.
Yeah. And it also takes an array. So that is 0.3, 0.5, 0.2. Okay, they sum up to 1. You have to select it and call this value as k. Okay, call this value k, and if we just run the cell and try to see what is the value of k that you will get, it is 1. Okay, so anybody has any doubt? Just notice that it is giving you an array. Okay, so if you want to like extract the value, you have to basically put 0 here. Okay, and now it's giving a number. Clear, everyone? If it is clear, let's move towards the next problem. So we will now move to the step 2, that is sampling from the chosen distribution, or chosen component. So as we have sampled our or as we have chosen our component, we'll sample a point from the mixture k obtained from the previous question, that was this one. The means and the variance of the mixtures are as follows. So you have to sample the point now. So how will you do it? Okay, what
Sir, in
RNG
the
method? Yes.
sir, in the previous code, I'm getting error that you have forgotten the comma. So
Just
RNG
take
dot
whether,
choice.
just see the array. Okay, you should have put comma between the elements in the array, and the parameters also between the parameters. Just check where you have not put the
Yes,
comma.
sir. Yes, sir. Thank you. Yeah, I actually have forgotten here in P. Okay,
Okay.
sir. Thank you.
Okay. So now, given this mu k and sigma k, and you have chosen this component k, how will you sample the data point from the kth cluster or the kth component? So again, we will be using this RNG method. So there's something called as RNG dot normal. Okay, which basically samples from normal distribution. This RNG dot normal takes again the 3 parameter. Okay, so also sorry, just run the question mark. Okay, or sorry, normal. Okay, so the size parameter here equal to none. So we talked about in the last time also. If it is given that in the doc string that something parameter value to be none, that means it is optional. Okay, if you don't put size equal to something, it will basically give you only one random sample. Okay, and the other, yes.
Sir, here normal, is it an attribute of that thing, RNG?
Yeah, RNG. Yeah, it is the
Um,
attribute.
so how does this differ from that SciPy norm?
Okay, here you have to SciPy norm. Okay, so there also, but see what the SciPy norm will do. It will calculate the density function value. Okay, in which it will take the mu, sigma, and the xi data point also, at which you are calculating the PDF of the normal distribution. This RNG not normal. It only accept the sigma and the mean, and then it will randomly sample from the that sigma and with that mu, it will randomly sample your data. Okay. So this LOC and scale are basically your mu and sigma. Okay. So let's close it. So let's define your mu. So the component that we got was 1. So mu1 is okay. So 1 means it is the second one point. Okay. Because here we are taking the 0 indexing. So 1 means the second. Okay. So so we will take the 0 and 1 here. So mu is we say let's do it -4 0,5. This is your entire mu array. The sigma array is 2, 1, 3, and now you can do it. Okay, so the whatever the k we have selected, we are only taking that positional argument. Okay, I hope it is clear. Okay,
Sir,
wait. Yes.
Sir, I don't understand why we are taking this normal distribution.
Because we are taking the Gaussian, right? Our GMM
Oh,
is
yes,
the
yes, sir,
Gaussian.
yes. Right, right. Thank you, sir.
One mistake that I did, that was this, that because they are sigma square, so we have to take the square root. Okay. So we have taken the square root and everything looks okay. So let's try 0.93. Okay. That is the sampled data point that you will get. Okay. Is this code clear to everyone?
Sir, I'm getting wrong.
Okay. Just look at whether you have taken the. Did you take the square root in the sigma part? The square root, okay.
Sir, wait.
Here, k takes all the values.
No,
That's mu
it's
sigma.
only take this k that we defined here.
Okay.
That is 1. Okay. So it is like if you just directly give RNG dot normal with mu 0 and variance 1. What happened? Oh, no.
L is missing, sir.
Yeah. Okay, it's the same thing. If you just directly give it, or you make the array of mu and sigma and then just pass the key. But we are doing it in this way because we will be using this later. Okay, the same method. Let's keep it like this. I hope it is clear for everyone.
Sir, in the question, we have been asked to compute for 1.
Yeah, only for the point from the mixture K that is obtained in the last question.
Okay, sir.
Okay. So the problem 3. Now that we have sampled 1 point, we will sample 3 to 5, 6, 1 lakh point from the GMM, and we will generate each point step by step. That is, first we will choose the component, and then we will sample from that chosen component based on the sigma k and mu k value. Okay, and we will create one array which would be of shape 1 lakh comma. Okay, and where each value will hold the ith point generated from the GMM. Okay, and we have to calculate the mean of that final vector. So just repeat the 2 steps that we did. Okay, only thing that we have to do it for the whole, what we say, for we have to do this for 1 lakh iteration. That is, we can run the loop. Okay, so we have already defined these mu and sigma array, so I'll just copy paste here. Okay, let me define the pi array also. That is the probability by which we will be choosing the cluster, that is 0.35 and 2. Okay, now next is what? We have to sample 1 lakh data point. Okay, so let me first write it like this. Okay, that is the number of data points, and I am creating one array of x, which is the 0 array. Okay, so this np dot zeros will create an array of size n. Okay, of size n, in which all the elements would be just 0. Now why I am doing this? What I will do, we will run a for loop. Okay, and in each iteration we will update this ith xi value. Okay, so in that route we are going, it is for I n range n. What is the first step? We will sample. Okay, the data we will select the probability of choosing this. So maybe not here. And let's call this k. Okay, and we can replace this p with pi. Okay, so this was the first step. The second step that we did was this. Okay, rng dot normal. Okay, and this represents the xi value. Okay, the ith value. Okay, and we will update it. Okay, and maybe just x. Okay, any doubt, anyone in this? We have just defined the 3 array, that is the mu k, sigma k, and pi k. Then one n, that is the number of data points. Then we have created a 0 array of size n. Okay, then we are iterating through a for loop. Okay, in which in each iteration we are first selecting the component, and based on the selected component we are sampling from the normal and updating the ith point in xi array, and this would be your final x. Is this code block clear to everyone? Okay, what in the question it is asking is the mean of the vector x. So how you find the mean?
X dot mean or np dot mean.
Yeah, same. Okay, so negative 0.193, that would be your mean. Okay, so I hope it is clear. So let's move toward the problem 4, which is about the plotting the histogram. Okay, so let's, what was the method? Okay, it's already given, plt dot test. Okay, we discussed this in last session also. What parameter it will take?
Bins.
Yeah, bins. And what is the other? The array itself, right, from which you will be plotting. Okay, so let's first start with 10 bins. Okay, let's use this. So it is giving some, if you go on full screen, okay, this kind of shape. Okay, so let's change the bin. Let's move this bin to 50. Okay, now if you see, okay, this looks much better than before, and it's look like there are 3 different Gaussian. Okay, now let's, if we make it 100. Okay, this is more better. Okay, and in which we can clearly identify this is one Gaussian. Okay, that's this another Gaussian, and the third one here. Okay, so you can play around with this bins. Okay, try increasing and decreasing. I hope this histogram part is clear. Okay, let's move toward the problem 5. From here we will start our EM algorithm. Okay, so it will be break into 5 stages. Okay, first step is about initialization, then E step and M step. We will decide the stopping criteria, and finally we will execute our algorithm. Okay, so all the 4 steps we will write 4 different functions, okay, related to this stage, and then all these functions will be eventually clubbed into one function, okay, and which will run our EM algorithm. Okay, it is modular approach for dividing code block. Okay. So let's directly go into the problem 5. So write a function init that initializes the parameter of the GMM and returns theta naught, which is of numpy array of shape 3k, in which the first k element of theta naught represents the mean of the 3 mixture. That is, the first 3 would be the mu k, the next k are the variance, and the last k represent the mixture probabilities. The exact value that we will be using are given here, and we have to find the norm of the theta 0. I hope the question is clear to everyone. You just have to write a function in it that initializes your theta naught, okay, and it will return an array of size 3k, and with first k element would be mean, the next 3 are variance, and the next 3 are mean. Oh, sorry, the mixture probabilities. Okay, so let's write def init, and it will just simply return and numpy array, okay, in which the first 3 parameter are mean, so it is 1, 2, 3. Now next 3 are variance, so 1, 1, and 1. The next 3 are mixture probabilities, so 1 by 3, 1 by 3, 1 by 3. Okay, and that's all. You define your init. Okay, next thing is you will run this function, and theta naught, okay, you have to calculate the norm of this theta naught. Okay, so what is the function for calculating the norm using numpy? How you calculate the norm of a array in NumPy?
Sir, I think there was function norm.
Yeah, but should I directly write np.norm? Or is this norm function also belongs to any other module?
SciPy, sir.
SciPy is different library. Okay. With NumPy, tell me.
Like how we did before.
We have not calculated the norm before. This is, I guess, the first time we are encountering the norm.
Sir, I think we did in one of the last. We have calculated
Yeah,
norm
yeah.
in
In
clustering, I
I guess,
think.
yeah, in clustering we must have calculated. So it comes under linear algebra package. Okay, linalg, this module. Okay, and in that we have this norm. Okay, and this class is theta norm. Okay, it will give you the norm. I hope this question is clear to everyone. It's just simple. You are just initializing your array and nothing else. And this norm.
Sir, can you please explain what we are doing here?
We are
The
first
whole point.
initializing our theta naught. Okay. In the EM step, that is our first step. Okay. You initialize your parameters. Okay. The next step is E step and M step. Okay. And then you update and stopping criteria. Okay. Like so, we have break down our problem into here. See the 5 steps. So
Yes, sir. Yes, sir.
initialization is done.
Understood.
Next, E
Sir,
step.
can I ask who has created these notebooks?
These are collectively created by instructor for the MLT, like Karthik sir, Nitin sir, okay, Ambika ma'am. So many instructor created this, not one.
And sir, for all the weeks, we will have these programming sessions as well for
No,
all that.
till week 10 only we have programming assignment. Week 11 and 12 don't have it.
Okay,
Okay,
sir.
so till week 10 only we will be having that. Okay, the function E step. Okay, what does each step function do? It accepts the parameter theta and x as an argument. It should perform the each step and return in lamb of shape n comma k. Okay, we have seen a similar matrix today when we were solving the solve with us today, right? The same matrix that was also of order n comma k. Okay, the where lamb ik, okay, ith row jth column entry is equal to same as lambda ik value. Okay, for the purpose of the evaluation, run the function on theta naught and x that we calculated before. Okay, call the returned value lamb1, compute the sum of the 0th column of matrix lamb1 and enter that as your correct answer. Okay, now one aside question that it is given to you. We prefer the variable name lamb over lambda for a reason. Can anybody tell me the reason for that?
Yes, sir. Because lambda is an inbuilt function in
Yeah,
Python.
lambda is
That's
an inbuilt function in Python, and that is used to define anonymous function without names. Okay, so that's the reason we cannot select lambda as our matrix name, and we will just go with lamb. Okay, so let's try calculating it. So it takes two parameter theta and x, the step. Okay, so so for this we need to calculate the Gaussian function. Okay, because we need the normal. So let's first create the Gaussian function. Okay, which basically takes the x, mu and sigma. Okay, we did it yesterday also, right? We defined a normal. We defined a function to calculate the density for the normal distribution, right? So I will just copy paste from one of my previous. Okay, that was the denominator part, and it is the numerator part. And numerator by denominator, we will take the Gaussian.
Sir, can you please share this in chat?
Okay. Okay. So we defined it yesterday, so that's why I'm not doing it again. Okay. So now let's go over the each step. So the first step we will be needing is we need to separate our mu, sigma, and pi. Okay, so that we can access them differently, because we need to calculate different values. So first, let's calculate how many n we need, that is how many data points that we have. That would be just simply x dot shape. Okay, x dot shape returns a tuple. Okay, so that's why we will put this. Okay, x dot shape returns a tuple, so we need the first element, so that's why this 0 came here. Now we also need the k, that is the number of components that we have. Even though you can directly define k to be 3, but as we want our functions to be more flexible, okay, so that even for any other it can also work. So that's why the way we will be doing it here is theta dot shape, okay, 0. This will again give us the shape of theta. Okay, so theta, if you remember, this is of shape 9, comma 1. Okay, so 9, and the component is basically what, by 3. Okay, so we have 3 components. Okay, now we will separate our mu, sigma, and pi from this theta. And how we will be separating them is, we know the position of them, right? That is, the first k are mu, the next k are sigma, and the next the last k are pi. So it would be theta till k. Okay, then for sigma it will start from where, from k till what should I go, till how much, should I take? Yeah, correct. Okay, till 2k, and theta we will go with 2k and till the end. Okay, I hope it is clear. We are just separating this value. Now next is, we'll create this lamp, just how we while calculating our x, we created a zero array. Here also we will create a 0 matrix. Okay, np dot zeros, and that is n comma k. Okay, this np dot zeros, here it will take a tuple. Okay, because it is of order n comma k. Okay, so get back to the definition for calculating lambda ik. How you calculate? It is basically, again, you can think of it like as a posterior probability. So that is prior into likelihood divided by evidence. Okay. So for each xi, for I in range n, we'll first take each data point. Okay, now for this one data point, okay, you will be going to calculate that value, pi summation from I equal to 1 to k. Okay, pi k nk. Okay, that value you need to calculate, right? Okay, so that would be your denominator part. So the way, now here we will be using, I will be using the list comprehension method. Okay, because it is a denominator, so that is the evidence, and that is if you remember how you can write what we say list comprehension method for for loop, it is like for k in range k. Okay, what we have to do, we have to take the pi k, so that is pi k into nk, so n means the Gaussian function. Okay, this we need to do, and we need to take the mu k and sigma k. Is this part clear?
Sir, can you please explain?
Okay, sure. So see, first what I am going to calculate here is the denominator part for the data point. Okay, and that is basically summation from pi k n k, right, from I equal to 1 to k. Okay, so this comprehension method, do you know this list comprehension?
Yes, sir. Yes, sir.
This way of writing. Okay, so what it will return, it will basically
Okay, sir. It's, I
return
think
this.
it's going to give us
It will give
mu
a
sigma and
it will
tau.
give a list. Okay, first of all, it will be a list. Okay, in which it will have the value for different keys. Okay, so let's say the first component you get the probability 0.23, for the second you get 0.35, and the third one you get 0.83 something. Okay, so it will going to get that list. Okay, but we don't want the list, we want the summation from that, right? Because it is basically the summation from one. So just use this sum function. Okay, so if you do this, you will basically get the sum. I hope this evidence how we are calculating it is clear.
Sir, can you run that without the sum? I just want to see that.
Okay, run. So maybe we can take the example, some example. So let's define something. M equal to 5 or 4. And second, I for I in range M. Okay. 0, 1, 2, 3. Let's give you this. Okay. Now here instead of this k, we are just doing this whole thing. Okay, and that will come as a list. And you
No,
will,
sir.
yeah.
So in this, we will get only 3 values now, sir.
Yeah, in this one we will only get 3 values because the k is 3. Okay, this
Okay,
is
sir,
just
that's
for
what I
example.
want to visualize. Okay, sir, fine.
Okay, maybe I will just leave it as comment here. Okay, now we will move towards the next part, that is the numerator part. Okay, numerator part for this lambda ik, and that is basically the prior part and what we say likelihood part. So that also iterates over k, because for each different k it will be different. So it would be
So this
for
part,
k.
evidence part, we have defined this under function, or is this outside function?
Uh, everything is
Okay,
inside
it's
function
within.
because
Okay, sir.
everything would be inside. Okay. Okay. So what is the first thing, that is prior probability? What is the prior probability? In this setup, what is the prior probability? Choosing the component, right? Choosing the component is your prior probability. And how you will get that here? Prior is pi k, right? Of course, small k. Okay, this is your prior probability. Next is likelihood. Okay, and this is basically the Gaussian part. Okay, so this Gaussian part here, same. Okay. Till now, is it clear? Okay, we have calculated the denominator, that is evidence, prior times likelihood. So it is pi k nk divided by the summation. Okay. So maybe if I just open, can you see this step? Okay. So this pi k we have calculated, this nk we have calculated, that is with okay, sorry for that. So this pi k and this pi k denotes the prior probability. This is what our likelihood and the summation that we were doing inside that list comprehension. Okay, that was this. Is this clear now? I hope. Okay, so what's the next thing
Yes,
for
sir.
calculating lambda ik? We need to divide, multiply prior into likelihood divided by evidence. Okay, so that is prior into okay, so like good.
So this notes that we are seeing now, is this also available on portal?
Yeah, this one I already uploaded that I shared. So now we will do prior into likelihood divided by evidence. Okay, and this is what this denotes the lambda ik entry, right? So that is lam I k entry. Okay, any doubt?
So the last line,
This,
what does this mean? Yes, sir.
okay, if you scroll above, this lambda ik value is equal to this, right? And that's what we did. Okay, we calculated this probability, okay, and make it equal to this. Okay, here it is, we are initialize our lambda matrix in which we have all zeros. Now we are replacing that entry with the probability. Got it?
Yes, sir, understood. Thank you.
Okay, and that's all. There's an each step, and we will return the lamp. I know it is a little bit heavy. It will take some time to digest. Don't worry. Okay, but just look at the formula, okay, and try comparing them side by side. Then probably you will be able to get it. Okay. So now, as we have defined our each step, the next thing that we will have to do is what it is asking. Okay, compute the sum of the zeroth column of matrix. Okay. Okay, no. First, we have to run the function on theta naught and x, and the value we will get is, we will call this as lamb1, and then we will compute the sum of the zeroth column of lamb1. Okay, so the each step that we defined. Okay, we will run this each step on the theta naught. Okay, that we defined above, and x, and then we will take the first zeroth column of this matrix. How will you take the zeroth column? How will you slice the zeroth column in this?
Colon, comma, 0.
Colon, comma, 0. Correct. Okay. So, see, in the matrix that is defined as a numpy matrix, okay, the slicing works like this: row, comma, column. Okay. The comma before comma, it denotes the row. Okay, and then after column. Now, if I type colon, it means I am getting hold of all row. Okay, and here if I just do 0, that means what I want in the 0th column, I want the entry from all row, so it will give me the first column. Oh, I mean the 0th column. Okay, is the slicing clear? Okay, now next is, it is asking to sum of all these elements. Okay, that is the sum of this column that you will get. And what is the function for that? If you have any numpy array or matrix and you want to find the sum of the element of that, how you find that? It's similar to how you find the mean. Okay, so for mean, what you will do, you will type this dot mean. Okay, same it is for summation. Okay, so just type dot sum and hopefully it should work. Okay, it's given a name goes in is okay. We did not run this cell. Now let's run it again. Okay, 68,226.19. Okay, this is your answer. Okay, now can anybody tell me if I find this value, what would be the answer that I supposed to get? Can anybody guess this answer? First of all, what does this mean? Lamb1 0. What this will give me?
Pick the first value.
Not the first value. It will give me the first row. Okay. If you don't put any comma or something and just normally, because see, think of a matrix again, just like your list of list in normal Python. Okay. So list of list, if you take the 0, okay, it is the first day, that is the row, right? Maybe if I write it here. So it is, this matrix is also in the list of list menu. Okay. So 1 cross 2, okay, 3 comma 4. Okay, so it is in like this. Okay, where this is the first row, this is the second row. So list of list. So when you only do this lamb1 0, so it will give you the first row. Okay, now if you are going to sum the first row, what is the value that you will get? For the lamb1 matrix,
What is the size of that matrix?
it is a further n cross k. So maybe look at this matrix again. Okay, it's the same type of matrix. Okay, I mean from order wise. Okay, in that also we have k column wise and n row wise. Okay, which is a further n cross k. Okay, so I am extracting the first row and summing the element of that first row. What should I get?
1, sir.
Okay, and what in the question they ask is the sum of the first column. Is it clear now what I was asking and how the matrix structure is? The matrix structure is similar to this, just how it is given here.
Sir, I'm actually getting 0. I'm not sure. Looks like I have made some mistake. Can you please show the code again?
This is the code. Okay, I cannot wait here like for much longer because
okay, sir. Then can you please share in the chat?
yeah, okay. So just see here, I got 1. So that means my function is working properly. So I will share the code here. So now let's change it to what they are asking. Okay. Sorry, my screen was not visible, right? So I made a change. So if I run with the first if I found the sum of the first row, I'm getting 1. So I hope my code is correct. And let's change it to back how it was. Okay. So any doubt, anyone in the E step? Okay, good. Let's move toward the M step, that is updating the mu, sigma, and phi based on the lambda k values. So in the M step, it accepts the parameter lambda and x as argument. It will perform the M step and return a numpy array theta. Okay. And nothing. Okay, nothing else interesting. We only need to do M step. So M step is basically update the value. Okay. So again, M step lamb and x. So what I will do, I will define k, that is the number of component that we have, that is lamb dot shape. Okay, what this will give me? This will give me the tuple, and that is n cross k. What I want in the tuple is the second entry, so that is 1. Okay, I hope it is clear. So now we need to update the mu, sigma, and pi. So again, we will going in the same fashion that we are following, that we will create a zero array for each of them. Okay, as there are k mu, k sigma, okay, and k pi. So we have created the zero array for each of them. Okay, till now I hope it is clear. Okay, next step is we need to update the value of mu, sigma, and pi. So we saw this before, how you update the mean, variance, and sigma. Okay, so that is, we will again run the loop for k in range k. Okay, the mu k would be updated as, what is the formula for updating mu k?
Process summation of I1 to lambda ik something.
Summation from I equal to 1
yes.
to n, okay, lambda ik xi divided by lambda xi. Okay, now I want you to focus again on, let's get back to this matrix. Okay, this is a lambda matrix. Okay, and suppose this is your data matrix. Okay, so if you want to update the mu1, what you will take? You will take the first column of the matrix, right, and multiply it with the data matrix. Okay, and divide by the summation of the entries that are there in first column. Okay, now I will implement the same thing in the column, that is, I will slice the first column, or means the kth column, because we are iterating over k, multiply that with the data matrix x, and divide that by the sum of the kth column. Okay, so mu k is, first I need the ith what we say column, so lamb by k. Now I will multiply this with x, the data matrix. Okay, we'll multiply it with x. Okay, and whatever you will get, you have to sum this. Okay, if you don't put this sum, okay, here, okay, if you don't put this sum, what you will get as the output for this is the vector. Okay, that has the basically the entries for only the multiplication. Okay, if you don't put this sum here. And you need to divide this whole thing, okay, with the summation of the kth column of the lambda matrix. Okay, that is just this dot sum.
Instead of putting the sum after, we can put it before also, no?
Okay, you mean in the starting here?
Yeah, before it'll give only single brackets, then some lamb like that, some bracket lamb.
Yeah, I got your point. Let's try with that if it works. Let's try if it works, then it's good. Okay, you can try with that, but okay, let's see if it either it will throw an error or it will work,
Okay.
because it is a numpy array, so not sure whether it will work here or not. Okay, let's see. So same way you will update the sigma k and pi k. Okay, so for sigma k you will do, what is the formula? Lambda ik summation from I equal to 1 lambda ik into x minus mu k square divided by again the sum. Okay, so it is x minus mu k, okay, and this everything we will square it. Okay, and we will multiply it with the ith column, right? Oh, sorry, the kth column, not ith. And whatever you will get, we'll just sum it. Okay, and divide it by this. Okay, is the sigma part clear? Okay, okay, so should we move towards the pi k part also? Pi k is, it is simple, right? It is just the summation of this. Okay, and we will divide with by the n, that is the number of data points. So maybe, okay, here let me make one change. Okay, so I have made one change here in the code. Okay, before I write k equal to lamb dot shape and the one. Okay, now I am just directly returning like this. Okay, so that I don't need to write it again, and I will just simply put here this n. Okay, is it clear, the updated of mu, sigma and pi? Okay, and if you want to compare, you can compare it here. Okay, we take the lambda and xi for the mu k. For sigma k it was this, for pi k it was this. So our final step is we need to
Sir, the change you have made n comma k,
yeah,
lamb dot shape, this will give row
see
comma
the
column
lamb
or
dot
column
shape,
comma
when you try with the shape argument, okay, for any numpy array it will give you a tuple. Okay, so this lamb dot shape will return the tuple in the form of row comma column matrix. Okay, so there are n rows and k column, so it will give n comma k. Okay, so the rows will stored in
n should be the number of data points, it should be rows or number of columns.
n is number of data points, that is number of rows. Okay, just again let's get back here. Okay, see this matrix, it is of order n cross k. Okay, your n varying like this. Okay, and k is column wise.
Yes, sir.
Okay, now we need to do what? We need to concatenate, okay, the mu, sigma and pi, because that's how we are defining the theta. Okay, and that how first k values are mu, the next k are sigma, and then last k are pi. So in return we will use the numpy argument, numpy function. It is np dot concatenate. Okay. Yeah. Okay, it this will uh, we will just pass mu, sigma and pi. Okay, is it clear, the m step? Good. Now what is asking in the question? For the purpose of compute the value of function for lambda 1 and x. All this return value is theta t1 and enter the norm of that. So theta 1 is m step lamp 1 comma x. And what was the how you calculate the norm?
Linear algebra. Linear ALG.
Lean
Yes,
L.
sir.
Okay.
Yes.
And norm?
Sir, is there no inbuilt function to compute these? Every time we have to write from scratch for this EM algorithm.
Yeah, nothing. At least in like NumPy, it is not. From sklearn, I'm not sure. There might be something in sklearn. I'm not sure about that.
Okay, sir.
Okay.
So, sir, there is no package for EM algorithm?
I'm not sure about sklearn library. Okay, in sklearn library, it might be there. Okay. For NumPy and matplotlib, that is the basic library that we are using. It is nothing.
In SciPy, sir, because these matplot, these are for visualization, but SciPy is
For
for
SciPy is basically more towards the optimization problem purpose. Okay, so SciPy, I doubt it will have. That is probably mostly for optimization relation.
Okay, sir. And in this Lin ALG module,
yeah, it basically have the functions regarding the linear algebra operation that you do, like norm, eigenpair. Okay, for those type of operations are there. Again, you can put the question mark, okay, and read the document. So hit enter and we got this value 8.69. Okay, now final part, that is we will be calculating
sir,
the
can you please show the prior code last line? NP dot
concatenate. Okay, just put control plus space. Okay, it will give you suggestion. Okay, when you type the concat and you forgot what it takes, control plus space, it will give you the suggestion. Okay. Okay, now this is not the final part. First we have to calculate the distance between the theta t and theta t plus 1. Okay, so that is theta naught and theta 1. So it is very simple. If you want to calculate that, write a function def distance. Okay, this distance function takes two vector theta t and theta t plus 1. Okay, so maybe I will call it as theta old and theta new. Okay, and what it will return? The distance between them, that is np dot again lin l dot norm of theta old minus theta new. Okay, I hope this function is pretty simple. It should not have any problem. So we'll calculate the distance on theta 0 and theta 1. Okay, this stands. Anybody has any doubt in this function? This is pretty simple. Okay, let's subtract the two vector and find the norm. Clear?
So this is just for first row, right? The distance, or is this taking for like entire? Is this for just
theta,
one?
theta is the parameter. Okay. So the theta, Ravi, I will get back to you in a few minutes. Okay. So theta naught is the collection of the parameter that we started with. Okay, that is the older mu, sigma, and pi. Theta 1 is the vector which contains the updated parameter in the m step that we did, right? That is the updated mu k, sigma k, and pi k. So those two are the vectors. Okay, and we are basically,
But
if you
there we have like three. There we have three parameters, right, sir? And when we are like differencing here, theta old minus theta new.
Okay, just look here. Okay, look at this picture. This is how your theta naught. Okay, it is in one row and one, like, okay, in which the first three are your mu, the next three are your sigma, and the next three are pi. But it is not like exactly like this. Okay, they are basically, okay, theta, okay, 0 is basically this. Okay, in which your the first three are your mu, the next are your sigma, and this next are your, okay, this is how your theta naught it is, and theta 1 is your updated version. Okay, and they two are basically vector. You are subtracting to vector and taking the norm. Okay, you see here, this is how we made our convergence criteria also. If that distance is less than some epsilon value. Clear?
Okay, sir, understood. Thank you.
Yes, Ravi, what's your doubt now? Ravi,
Can you go to the previous question for a minute?
in the m step.
Yes. Which question? I guess 7. Question number 7.
This is question number 7, problem 7. We are defining m step and updating our theta.
Okay, I have done this. Okay, sir.
Okay.
Fine.
So now here finally we will run the entire EM algorithm. Okay, from start to finish we will run each step and see. So question is, perform the EM algorithm until convergence. The stopping criteria that the distance between two should be 0.01. Okay, initialize the parameters to theta naught and find the number of iteration it takes algorithm to converge. Now it will take quite a long time. Okay, not that much long, but it will take a long time. Just so first I will define epsilon and iter, okay, to be some value like epsilon is 0.01 and iteration to be 0. Okay, and then I will define the theta. Okay, theta and theta previous. So, okay, now why I am using this is because every time we will calculate the distance of this updated theta and the previous theta. Okay, So while the distance, between theta and theta prep, okay, is less than epsilon. Okay. Okay, no. We have to run the loop until it is greater than epsilon. Okay. Okay. Until okay, I have spelling error. Epsilon. Okay. We have to run the loop until this distance is greater than our epsilon, that is the stopping criteria. And what we have to do, we have to perform the E step and the M step. So from the E step, we will get this, in which it will take the newest theta that we have operated. Okay. So it will, the E step will give you a matrix lambda. Okay. And in the M step, okay, what you will get is the updated theta. So that is your new theta. So just look how I am going to write it as theta and what we have, theta prep. So theta previous theta. Is this look good for you? So the previous theta, we are replacing it with the theta that we currently used here, and the new theta will become the M step theta. Okay. And for each iteration, we will increase the iteration value, and that's all. We will print the iteration. Okay, theta initialized, updated, previous to current to new. Yeah. Okay, let's go over it again. So first we have initialized our epsilon and iteration, epsilon to be 0.01, iteration to be 0, and theta and theta prev. For new theta is theta naught, theta 1, and theta previous is theta naught. Until the distance between theta and theta previous is greater than equal to epsilon, we'll perform each step from which we will get the lambda, and based on this lambda we'll update this new theta. Okay, so that would be M step, and the previous theta is assigned to with the theta, and increment the iteration and print it. Any doubt?
So this iter will give us how many iteration it has done.
Yeah.
Open while, is that right?
Yeah. So how many times it has done? Okay.
It has given 7.
7.
Yes, sir. I got 7. Yes, sir. I got 7.
Some mistake might be there, because first
how
of
many
all,
should we?
First of all, it should not run in few minutes. Okay, it will take some time.
It has already run, sir. Actually, I was writing parallelly, so
most likely it will take. You must have made some error before. Oh. Why we got 7?
So can you please explain what is the error? Why not 7?
Okay, because the answer was, I guess, more than 7. The answer was not 7.
Okay.
Let me check the answer. Okay, 72. First of all, it should not converge till this early, because as it is also written, it will take some time.
Sir, for me, it's showing theta 1 is not defined, and then previously it was showing lam 1 is not defined. Why is it showing like this?
Probably try running the whole collab again. Okay, so Control plus F9, if you press, it will run the entire collab from the starting. Sometimes it might be glitch from the collab side also.
Okay.
So that's what I am also doing. Let's check if it works. Okay, I guess now it is should work because now it is taking time. Oh, no, again. Okay. If I iterate with someone, that will not make any difference though. Okay, we have defined our theta 1. Distance is greater than epsilon. Okay, we got right answer till here, and this E step is also working. While this distance is greater than epsilon, .01. Okay, it is also correct.
Sir, in the last line, can we add and see what is the epsilon value? If it's greater, then we know that it's correct.
Oh, no. Let's print the distance value, not that. If the distance, what is the distance? Yeah, I have to also print it. Maybe I will stop it. So 9.07, 5.9.
It will keep running until 7 iteration.
Okay, the value is decreasing. And
Sir, I think it's right only because if you see the last one, it's 0.0002.
Yeah, that is okay. The answer in the portal answer is 72. Okay, and the range is 70 to 75.
72. It's a huge difference.
Yeah, that's why we are just the 10th part of that.
So did we miss something for shape by any chance?
I don't think so. Let's check from the starting. Let me check from the starting. E step. So we did this. Okay, we have defined mu sigma pi, separated that, and for each range we are iterating our xi. Found the sum. Okay, I hope in the m step this won't cause any problem. I hope it should not, otherwise it would have given error. Prior and likelihood, and ith value is this. Okay, this is also okay. Each step look okay. M step. Okay. Okay, we did this mu sigma pi for each range. Okay, let's do an experiment. So m equal to np dot array 2 3. What is sum of m will give? Okay, it's working. X into lem just dot sum minus mu k the whole square. Okay, this entire term multiplied with lem and this. and when we are summing it. Okay, this is also fine. Then we sum over lamb. Okay, wait a minute. Okay, I guess I got it. We had these, right? So what we was given to us was sigma square, and we defined it only like this. So it should be np dot square root of that.
Okay, sir. In problem now. Okay,
Here
fine.
it was not didn't matter because all our sigma was 1, so even the square root and that was same because all sigma that was given to us is 1, so it did not matter that much. That's why we got the answer to be correct, but still. Okay, let's see if there's any more mistake. And in M step we
Sir,
don't.
can you please first show me what changes you have made? NP dot square is the only one change, right?
Yeah, I put everything in the np dot square root. Okay, then maybe just for understanding, okay, I will name it as variance just for the understanding, so that, okay, not in here, in the M step. Where is M step? So I will name it as variance so that we know. Yeah, okay, this is vendor by vendor, just for understanding, so that I just changed the name. Now should I try running? Okay, I'm running the whole collab. Let's wait. Oh, okay, I should not have do this. Should not do this. Otherwise it will take time. Let's comment it and run it again. Okay. So the only change that I made till now was I just put them in the square root. Okay. And I hope everybody know why before it was giving the right answer, because we had only 1. So the square root would itself be 1. So that's why even we got the right answer. Okay, now it's taking time. Okay, so till then, I just want to see how many of you are doing MLF together with MLT. Anybody here? Oh, okay, 1. Any other? Okay, except you, everyone has done MLF before. Okay. I will just suggest you one thing, that try going over week 10. In week 10, you will need the MLF part. Okay, till week 10. Before week 10, we don't need any more MLF part. Now straight in week 10, we will be needing.
So what is there in week 10?
It is about the KKT condition. Okay, so that KKT condition part you will study in MLF in week 10 only. So both week 10 you need to prepare together. So maybe first start with MLF week 10, then go over MLT week 10. Okay, now I think it will going in the correct direction. I just hope it will not get crashed.
So sir, it has to run through all those, I think 1 lakhs, right? Rows. We had.
Yeah, 1 lakh rows. That's why it's going to take so much time. It's running, I guess, from 2-3 minutes now. Okay, fine. Got the answer.
Yeah, 72.
Yeah, that was the only mistake. Okay, that we did not put the square root.
But sir, for me, I have got 71.
Okay, yeah, because I changed it to 1. Even in the portal, the range was given from 70 to 75.
Okay, sir.
Okay, so anyway, it will be. Okay, so problem. Okay, let us now verify the correctness of this algorithm. Okay, we know that true parameters are this. So this is the true parameter, and theta star with a parameter at the convergence, and we need to compute the distance between the original and the one that we got. Okay, so let's do this. It is simple. We have to first define theta original. Okay, that is num by array minus 4 comma 0 comma 5 comma 2 comma 1 comma 3 comma 0.3 0.5 0.2. Okay, and we need to compute the distance between them. So we'll use our distance function theta original and theta. Okay. This theta, if you remember, it is coming from here, this line, the updated theta. Okay, so oh, it's starting again. Don't start. So this is the distance that we will get. Okay, this is okay, it got started again. That's why I need to run it again now because I accidentally ran this cell. Okay, now we have to again wait for 3-4 minutes. Okay, so
Okay,
let's.
sir, what was the answer? What was the answer for this? 4.25. I
No,
guess 0.10.
Yeah, 0.10. Okay, so because I accidentally run this cell, so the theta value got updated to the previous. That's why. So maybe let's do the problem 11. Okay, I will tell how you do it. Okay, so the similar type we discussed. Okay, let's get back to the question that we discussed today on this. Okay, we discussed this question, right, in which the question was which component it is most likely to generate as a data point. So the way we do it is basically we calculate the posterior probability. Okay, so that was these. Okay, and yeah, well, okay, and whichever is the maximum, the data point is generated from that. And the same we will be doing here. If you see, the cluster assignment is given like this. That is the across the column which has the maximum probability. Okay, so I will just write the code for that. Okay, so what I will do, index. Okay, so our updated lamp. Okay, the lamp that we will get in the updated. Okay, there's something called as argmax. Okay, so argmax, it will basically give you the index number at which it is getting the maximum. But it will accept one parameter called axis. Okay, so the axis parameter will tell you along which side you should do the operation, whether the column side or the row side, or we say top to bottom, left to right. So as lamb is our matrix, okay, on applying Rmax function on this with axis equal to 1, it will check the maximum value across each column, okay, and the index at which that maximum value is present will get stored in the index. Okay, is this part of code clear? Is it clear to everyone?
So can you please explain again?
Okay, so lamb is a matrix of n cross k. The argmax function, okay, gives you the maximum where the maximum value is occurring, okay, and this axis is basically the column. Okay, so
sir, it will look for the highest value in that particular matrix and it will return the
not
index.
column wise. Okay, so let's say this is your matrix. Okay, in the first column the highest value is occurring at in the second index. Okay, so the first value in the index would be 2, okay, because it is occurring at index 2. In the next column it is occurring at 1, so the next value it would be like 2 1, and like that would be your array index. Okay, got it? Okay, now let's run this because we got our answer. So now 0.1. Okay, so let's now quickly do this. We have to 0 1 2 corresponds to the color red, blue and green, and color histogram we have to plot. Okay, so see how I'm going to do it. plt.test, okay, from x. Okay, so what we need to do, each data point is now assigned to some cluster, right, or some component based on this value, okay, maximum probability. So for ith data point where it is getting the maximum probability, it will assign to that component. Okay, now we have to divide our data set into 3 parts, okay, based on these, and color each 3 part. So from the x, I will take all the elements from the x where the index value is 0. Okay, I hope we have you remember this slicing method, this one. Okay, the next is just bins that we will define, and the next is color. Okay, the color that we will give here, so we will give red. Same thing we will be doing for 1 and 2, while we will color them as blue and green. Clear? Is it clear? Okay. Let's run this. So this is the output that you will get. Okay, and we can clearly see, okay, let's do the different annotation, black. So you can clearly see 3 different components in this. So EM here did a soft clustering method, okay, based on the probabilities, while if you run the k-means, it will do a hard clustering. That's all. Okay, yeah, that's it. There are some extra thing that make the stopping criteria more hard. Okay, you can make it and see if by how many times the number of iteration increase. Okay, try changing the size of data set and effect on its convergence. Okay, so these are the things that you can try on your own. Okay, you can play around with this, and that's it.
So can you share the collab link of this, please?
Okay, for this
in chat of a minute, so that I can follow it.
Just you have to give me 5 minutes. Okay. To create.
Can you repeat why were we getting 71?
Okay, 71 and 72. It's okay. So see, the range in the question was given from 0 to 75. Okay. So okay, not this. Yeah. Okay. So I initialize here it with 1. So that's why 72. If you initialize with 0, you will get 71. In the question, the range was from 70 to 75. So anyway, the answer would be correct for you. Okay.
Okay, thank
you. Yeah. So the collab.
Sir, on Sir, Friday's mentor session recording has not been uploaded on the calendar
Friday
invite.
mentor.
Yes, sir.
Friday on Friday we did not have any mentor session. We shifted the Friday. That means you means the yesterday, right?
Yes, sir.
The yesterday we shifted the yesterday mentor session to today from 5 to 7. Okay. So.
But sir, actually, I got invite today itself, so I have not attended any mentor sessions. I will be attending going further. So.
See, we have only started recording the from Wednesday. Okay. So. There's no recording for past session, only those 2 sessions that happened today and that happened on Wednesday. Okay, so only for that we have.
So sir, can you please confirm the next mentor session is on Sunday 8 to 10?
Yeah, tomorrow. Okay, I will be taking that.
Okay, sir. Thank you.
Okay, uploaded, done. Okay, the link.
And sir, what we are going to cover in mentor session today?
Tomorrow. Okay, yeah, it's almost today now.
Yes,
we
sir.
will be covering the questions from week. Okay, mostly PYQ and something. Yeah, also one thing that I wanted to tell. Okay, we have updated the calendar for the TA session. Okay, that is, and also for the revision session. That the next session for instructor would be revision session, and the next TA session would be the PYQ session. Okay. So in the PYQ, we will be covering for 6 terms, past 6 terms paper. Okay. Each session we will cover 2 paper.
So that is on Tuesday, right?
Tuesday, Wednesday, Thursday. These are the TA session timing. Okay, let me show you.
Tuesday, Wednesday, Thursday. Okay, sir.
Okay. So Tuesday we have this, Wednesday and Thursday. Okay. And
okay, 8 to
this
10.
is revision, and this is also revision. So from Monday till Friday, we have this.
Okay, Monday to Friday, yes, every day.
Each three, the 3 in between are fit TA, the first and the last one are instructor session.
Okay, sir. Thank you.
Okay, that's all for now. Good night, everyone. Thanks for
joining. Good night, sir. Thank you. Bye.
Good night, sir. Thank you. Bye.
Welcome.
Thank you so much, sir.
Welcome. Good night. I'll stop streaming.